Look up at the night sky. See those stars? Our galaxy alone contains over 100 billion of them, and there are over 2 trillion galaxies in the observable universe. That's more stars than grains of sand on every beach on Earth. So here's the question that should keep you awake at night. Where is everybody? Today we're diving into one of the most mind-bending puzzles in all of science, the Fermi Paradox. By the end of this video, you'll understand why this question has scientists, philosophers, and even governments seriously concerned about the future of humanity itself. It all started with a casual lunch conversation in 1950. Enrico Fermi, the brilliant physicist who helped build the atomic bomb, was eating with colleagues at Los Alamos. They were discussing recent UFO sightings and joking about little green men visiting Earth. Suddenly, Fermi went quiet. Then he asked the question that would haunt science forever. Where is everybody? His colleagues knew exactly what he meant. Given the age and size of the universe, shouldn't we have encountered alien civilizations by now? Shouldn't the galaxy be teeming with life? In 1961, astronomer Frank Drake formalized this into what we now call the Drake equation. It estimates how many communicating civilizations should exist in our galaxy right now. Let's plug in some conservative numbers. Rate of star formation, 1 per year. Fraction with planets, 50%. Planets that could support life per system, 1. Fraction where life actually develops, 10%. Fraction that develops intelligence, 1%. Fraction that develops detectable technology, 1%. How long they remain detectable? 10,000 years. Even with these conservative estimates, we get about 50 communicating civilizations in our galaxy right now. But here's the thing, we've found exactly 0. This is the Fermi Paradox, the contradiction between the high probability of alien life and our complete lack of evidence for it. Now you might be thinking, so what? Maybe aliens just don't want to talk to us. But the implications go way deeper than hurt feelings. The Fermi Paradox isn't just about finding alien pen pals, it's potentially a cosmic warning sign. Think about human technological progress. We went from first flight to landing on the moon in just 66 years. We've had radio for barely 150 years, and already our signals have traveled 150 light-years in all directions. A civilization just a few thousand years ahead of us should be incomprehensibly advanced. Such a civilization might build megastructures around stars, colonize entire solar systems, or send self-replicating probes throughout the galaxy. Given that the Milky Way is 13.6 billion years old, and it would take only about 10 million years to colonize the entire galaxy, even at slow speeds, where are the signs of these cosmic engineers? The silence is deafening. And that silence might be telling us something terrifying about our own future. This brings us to perhaps the most chilling proposed solution, the Great Filter. The idea is that there's some incredibly difficult step in the evolution from simple matter to spacefaring civilization, a filter that almost no species makes it through. The question is, where is this filter and have we passed it yet? Possibility 1, the filter is behind us. Maybe the jump from non-life to life is incredibly rare. Or perhaps the evolution of complex cells, multicellular life, or intelligence is the nearly impossible step. If so, we're incredibly lucky to be here, and we might be alone in the galaxy. Possibility 2, the filter is ahead of us. This is the scary one. Maybe intelligent species regularly destroy themselves before they can colonize space. Nuclear war, climate collapse, artificial intelligence run amok, asteroid impacts, supervolcanic eruptions. There are plenty of ways a civilization could end itself. Remember, we've only had industrial technology for about 200 years, a cosmic eye blink. We've already developed weapons that could end our civilization, and we're rapidly changing our planet's climate. Maybe every species reaches this critical point and fails to navigate it successfully. Some scientists call this the danger zone, the period where a species has enough technology to destroy itself but hasn't yet developed the wisdom or safeguards to prevent it. We might be in that zone right now. But the Great Filter isn't the only possible explanation. Scientists have proposed dozens of solutions to the Fermi Paradox, each more fascinating than the last. The zoo hypothesis. Maybe advanced civilizations are out there, but they're deliberately avoiding contact with us. Like animals in a nature preserve, we might be under observation, but protected from interference. Prime directive, anyone? They're already here. Perhaps aliens are already on Earth, but they're so different from us that we don't recognize them. They might live in the deep ocean, underground, or exist on timescales so different from ours that we're like mayflies to them. The transcension hypothesis. What if advanced civilizations don't expand outward into space, but inward into computation? Maybe they discover it's more efficient to build smaller, more powerful computers than to colonize planets. They might be living in virtual realities more interesting than our physical universe. Rare Earth. Maybe Earth really is special. Our large moon stabilizes our climate. Jupiter acts as a cosmic vacuum cleaner for asteroids. Our magnetic field protects us from radiation. Perhaps complex life requires such a specific set of conditions that it's incredibly rare. The Berserker hypothesis. Here's a dark one. Maybe there are self-replicating machines out there that destroy any emerging civilization. Any species that becomes detectable gets wiped out before it can spread. The galaxy stays quiet because speaking up is a death sentence. Despite the paradox, we haven't given up looking. In fact, we're getting better at it every day. The Kepler Space Telescope and its successors have found thousands of exoplanets, including many in the habitable zone where liquid water could exist. Projects like Breakthrough Listen are scanning the skies for any sign of alien technology. We're looking for radio signals, laser pulses, and even waste heat from alien megastructures. And we might not need to look far. Right here in our solar system, moons like Europa and Enceladus might harbor microbial life in their subsurface oceans. Mars might still hold fossils or even living organisms underground. The next few decades will be crucial. The James Webb Space Telescope can analyze the atmospheres of distant planets, looking for biosignatures like oxygen and methane. Future missions will drill into Europa's ice and Enceladus's geysers. So what does all this mean for humanity? The Fermi Paradox forces us to confront some uncomfortable truths about our place in the universe and our future. If the Great Filter is ahead of us, then our survival might depend on how we handle the next few centuries. Climate change, nuclear weapons, artificial intelligence, biotechnology, these aren't just policy issues. They might be existential tests that determine whether our species has a future. But there's hope too. We're the first species on Earth to recognize these risks and actively try to mitigate them. We're developing renewable energy, international cooperation protocols, and AI safety research. We're even taking the first steps toward becoming a multiplanetary species. And maybe, just maybe, we're not alone. Every day we don't receive an alien signal might just mean we haven't been listening long enough or in the right way. The universe is vast and we've barely begun to explore it. The Fermi Paradox remains one of the greatest mysteries of our time. Are we alone? Are we first? Are we just not looking hard enough? Or are we approaching a cosmic test that few civilizations pass? Whatever the answer, the search for extraterrestrial life has already changed us. It's made us think more deeply about our own planet, our own survival, and what it truly means to be human in an incomprehensibly vast universe. The universe is under no obligation to make sense to us, but that won't stop us from trying to understand it. Because in the end, whether we find aliens or not, the search reveals something profound about who we are and who we might become. What do you think? Are we alone or just not looking hard enough?